Welcome to FNC Maps and Mapping with a Database. You might be surprised that this video doesn't show me on camera at the TMS days in Belgium. The reason for this is pretty simple. We were doing sessions in two separate rooms, and because of that fact, my session started late and people kept coming in, and I wasn't really able to present the use case to everybody. Then I repeated parts of it while explaining the example. So all in all, the structure of the talk wasn't as good as I wanted to be. So I replaced this video with the complete session. So the content is literally the same if you've been to Bruges, Belgium that day. The content will be the same. However, it will be presented without any interruptions from people coming in. And also I will be able to present it without hurrying in the end. So this video might actually run a little bit longer than the 45 minutes that I had that day. I just want to make sure that the content that I wanted to present is actually being presented. Before I start with the actual session, let me start presenting the scenario, the usage scenario, because with me, you know, it's all about examples. I like to present practical examples that you can implement or incorporate into your own projects. In this case, we'll be looking at a garage sale or a yard sale, which are very popular in the United States. Over the weekend, mostly Saturdays or Sundays after church, especially here in the South, people put all the stuff that they want to sell out in the yard, and you can browse neighborhoods and look for stuff you always want, never knew you needed, and you can purchase them right there. My wife is a big fan of those. You know, whenever there's a yard sale in our neighborhood, I'm ready for more stuff to be added to our house. So with that in mind, the scenario is that you get invited to this yard sale and you are the organizer of this yard sale. And with TMS, you are able to generate the barcode to generate an invitation like this, which gets you to a web page where participants that are interested in participate in a yard sale can sign up. That is actually the next session that will be about TMS Web Core, where you learn how you write a web page with a form that allows people to sign up. There was a previous session about Flexel that allowed you to create a report with all the participants in the yard sale. So we hooked up the database to the Flexel reporting engine, created a template in Excel, and that's the report. Not this one, but this is an actual report I got sent and I built the example on. So this is what you learn in the Flexel session. All of this is supported by a database model. The database model in my case is in MySQL. You could convert it to any other relational database engine easily, like Microsoft SQL, Postgres. It's all possible. That's not the key point here. The point is you have a collection of yard sales right here in the yard sales table. Each yard sale is identified by an ID, and a yard sale has a starting date, an end date, and a title. And in addition to that, we have a logo and a thumbnail logo. That is something that is happening in the back end, so to speak. That will be shown if the sign-up page is generated, so you can present a logo in association to your yard sale. And then the X-Data server, because you present it on a web page, will basically generate the image in the size that is needed for the web page. You'll learn that in the Web Core session. Sales participant is linked to yard sales. So a sales participant participates in a yard sale, and that's why there is a foreign key constraint using the sales ID field. Sales participants in this case have an email address, a name, and an address. And that is actually important for the FNC Maps session. They have participants, they have a street, a zip code, a city, and a state associated with them. And from that information, using geocoding, we're able to calculate the longitude and the latitude. For the session, we assume that the longitude and latitude is already there because in a 45-minute session, we can't go into detail how do the geocoding in detail. I'll brush on it briefly, but the source code is already there. However, to explain the intricacies, how you calculate or do the geocoding for all the different participants in detail, in Belgium, we were not able to look at that in detail. Still, I'll explain it here and not only assume that the longitude and latitude is there. Also, as an added benefit, which is also being shown in the report, each participant is able to select categories of the items that they want to sell. And of course, participant items categories is a crossover table, and the item categories are having a name and an ID. So the participant item categories table is just a crossover table or a cross table between a participant ID and a category ID to identify which participant wants to sell which item. And of course, that links to the yard sale because each participant is linked to a yard sale directly. Here's the database opened in HeidiSQL, a Delphi application that you can use to manage your MySQL databases. And here's the tables, and I filled it up with some example data. So if you look at the yard sales, we got in the data part of the table, we have 2 yard sales, and we also have a logo, and the thumb has also already been calculated. You see there's just a title to identify the yard sale. And the participants right here, I created a couple of fake families with fake email addresses, and we see that the sales ID here, sale number 2, is actually the sale that we're going to be looking at. Sale number 3 just has one single item. And we also see that all of them have real addresses located in the area where I live, and that has already been used, if you look at the locations table, to generate longitude and latitude for all the different addresses. That is very important, and you might think, like, how can you link the location to the participant? Well, this ID here is the same ID as used for the sales participant. So the ID of the location matches the ID of the sales participant, so that's how you can match them up. And that's literally all you need to know about the database. There's nothing more to it. And you've used this database already for the Flexcel reporting in my first session, and now we're going to use these locations right here to pinpoint down where all the different participants are located on a map. So the mapping and reporting example is the one that we're going to use. And the most important thing, if you want to reproduce this, in the resources folder, you have to specify in the file name Google API key. You have to drop in a Google API key. What's that, a Google API key? Well, pretty simple. Whenever you want to use FNC Maps, that's this component right here, and you, for example, want to drop markers on a map like so, this is actually a full-blown Google Maps window, so to speak. And Google, even though they allow us to use their search for free, they charge for this privilege to be able to use their mapping service. As a developer, we get a pretty good deal. As far as I know, most of the requests that we do as developers are free, but for commercial companies, that might be quite different. However, this requires you to sign up with Google and to get a API key. If you don't want to use Google, and this is what makes FNC Maps so great, let me show that for you. So we open up the main form, and here's the magic component called FNC Google Maps. I used the Google Maps component, but you can also use alternatively the FNC Maps component right here, the FNC Maps, and that has a service property that allows you to switch between different mapping providers. I particularly wanted to use the Google service here, so we can exchange the marker icon. That's one of the features that Google makes very, very easily to use. So that's something I wanted to show. So I use the Google component right away instead of the general FNC Maps component. And the API key here is a string property where you have to specify the key that you retrieve from Google after signing up with them. The documentation of FNC Maps, or my book, explains this in great detail, how you can get a code from Google to use. So there's no need, there is no service property, it will always be Google. That's it. And what we'll do now first is I'll explain to you, if you have a database, the database that I've just shown you, how you can place these icons on a map that they match where the people that are in your database are located. And it's not really that big of a deal if you know how to use FireDeck. FireDeck makes this very, very easy. So I have a data module, and on that data module I have a connection that I link to my SQL database, and then I need to select the location so I can build the query right here if I know which yard sale, right? We have not only one yard sale in there, we have a couple of yard sales, which in my user interface right here, not this user interface, I apologize, in the user interface right here, as soon as it's compiled and run, I have a Dropbox of all the different yard sales. So for example, here I select one, and then I have the parameter. I actually print the ID right here. The number 2 is what I need to select in order to select all the locations for the matching yard sale. So going over to the participant locations query, I have to select from the locations table latitude and longitude, and only where the ID of the where it matches ID. So I'm actually not locating all the locations, I'm locating the location for one particular ID, for the ID of a participant. And how do I do this? Well, that's a little bit of magic from FireDeck, because if we look at the database model again, or at the database, how I built it, we know that we have the sales participant with the ID, and this ID matches the location ID, right? So for example, if I go to the participant here and I select, for example, the Flick family, and that's the 4. So 4, this is my location where the address that I specified in the database is located. And just like any other database, but I think FireDeck makes this particularly easy, you can select automatically, meaning like if you have a query that selects all the participants for a certain sale or yard sale, which is an ID, which is a parameter. So in our case, in this example, it would be 2. So let me set this to 2 right here, execute. I would get all the participants, but no location, right? The location is in the location table. However, I can left join that table in there based on the ID. So instead of just selecting from the sales participant table, I left join the location table, and that way I have in my query all the information I need in order to place the participants on a map. And I already filtered for the sale. So in order to do this, I just need to present all the different sales in my user interface, get the ID, specify the ID as a parameter in the participants query, open the query, and then go record by record to add the markers to the map. And that is done as follows. Going into the source code, we can go here to locate participants, and I split it up. We have the locate participants method right here, and I use a view controller, meaning I don't want to clutter my user interface with code that concerns the map, so I just call my view controller and I specify the selected sail, the ID of the selected sail, and I also pass the component, the map component. So I pass this component and the selected sail. What is selected sail? You might wonder, where does that come from? Well, it is a property right here, because what I do is, instead of working with the database directly, I read the sails from the database in a list of sails of type T sail. This is that T sail right here. So I have a sail with the fields from the database, and I use the data module that is tied to the database to retrieve these. So I have get sails right here, and it gives me a list of sails. And all I do in there is I disable the control so that my user interface doesn't flicker. I open the query, I go to the first record, and then I create the list, and then I add each of the sails, and tsail create, the constructor, has all the field by name calls right here, field by name ID, field by name event start, and field by name event end, to transfer the data from the data set into an object instance. And you wonder, why am I doing this? Well, it is just so you see you can transfer data from a data set into a list of objects and then work with these objects instead of keeping, for example, the dataset open the whole time, navigating through the dataset. Instead, you have a list of sails. So your user interface and the code associated with it is completely loosely coupled to the data model at that point, because you just keep inside of your user interface, or in your view controller, in this case, you just keep a list of all the sails. That's all you do. The advantage of this is that you can easily use your view controller or your data model in other applications without it being tied to this particular form. But let's not go too deep into the architecture of this application. Let's focus back on the actual implementation, how I add the markers. So we go to locate participants and add participants to the map. And the nice thing is, and this is why I structured this, you could literally rip this method out of this example and insert it into your own application if you have a list of your things, and then you can use this as a blueprint how to basically add stuff to a map. So let's keep the icon out of it first. The first thing we need to do, just like we have a list of sails in this application, we also have a list of participants. I read the participants into a list of participants. Again, I have an object class for that, and you find those in U mapping types right here. And there you see we have the T participant, which is an object instance, and we have the T participants, which is an object list of a participant. And then going over here again, we just iterate all the participants and then add their respective markers to the map. Before we can do that, the most important call is begin update to the map. A map in this case is a parameter of this method. And if you remember how we call that from the main form, we say add participants map. That's the control on the form. So we call begin update. And that is very, very important as soon as you add more than a couple of markers. In this case, it wouldn't make that big of a difference. However, as soon as you add like 100, 200, 300, 400 markers, if you forget the begin update, after adding a marker, the map would be redrawn. And it would also trigger basically interaction with the Google Web Service in this case. If you use and begin update and then end update, this is the point when the framework communicates with Google and redraws everything. So that is the way to do it, because it saves you a lot of cycles of redrawing and recommunicating with the Google Maps API. So in this case, this is the most performant way. And we clear the map, meaning everything that's on the map, like all the annotations that you made, you can with FNC Maps, you can not only make annotations like adding markers, you also can draw shapes on the map, you can add routes to the map, which we'll see in a bit. And that is all taken away, the map is clear. And then for each participant, stored in L participant, we look if this participant has a location, and if the participant has a location, we add a marker, and add marker has either you can use the coordinate data type, which is a data type in FNC Maps, way too complicated in this case, just use a latitude, a longitude, and you're good. Those two coordinates, then add the marker and with a title. And also, and this is the reason why I use an object instance, or why I built this example in this way, here you see how you can tie an object instance to this marker. So if you wanted to add functionality later to add interaction to this marker when somebody clicks on it, you present more information about the participant, you could do that, and you could reference the L participant object this way. Of course, if you want to keep the database approach without using any object instances, you can of course also use data string or integer, for example, for the ID of the record. That would also be a viable approach. As always with Delphi, flexibility wins and makes Delphi so great. And finally, instead of just using the default icon, so let's unmark this icon URL call right here. What happens then if we do that? Because the sail icon is something I customized, and by default it would look very much different. As soon as it compiles, I'll show you what it will look like. So instead of having little sail signs, we just get these default marker icons, which are not as fun. But how do I do the marker? Well, the icon URL can be something like specifying an image file, right? You could literally specify HTTPS, very important. HTTP is no longer really supported. TMS also built some mechanic into FNC Maps that you can use local resources. So I think here you can check local file access, set that to true. Still, Google recommends not using any local resources, not using HTTP. So my recommendation is if you have a resource and you don't have the ability to specify a URL, which HTTPS, and you want to use a resource that's included in your application, well, you can use a so-called data URL. A data URL is, in the web world, a resource encoded as a URL. And I recently learned about them, and they're so powerful also for usage in TMS Web Core. That's why I included them in the second edition of my TMS Web Core book. And you can use them pretty easily in your VCL applications as well. So L icon data URL is a string, as you can see here. And I load a PNG image into this string. Well, how do I do this? Well, first of all, I wrote a method to draw all this code that you see here out of that thing, and I load a graphic from a resource. How do you load a resource? So the resource is called sail PNG, and if I go to the resources.rc file, .rc files are linked automatically by Delphi into the executable. And RC files have a description what is supposed to be included as a resource. For example, here I include the template for the flex cell report. Again, see the other session. I include the Google API key as a resource in the executable, and I include the PNG file with the identifier sail PNG and it is located right here. So if I go now on my hard disk, hopefully I'm not showing anything you shouldn't be seeing. Nope. Here, this is the example, and then there's the ... resources. I go here, and then there is the sail icon file, and I include the sail32 PNG. That's this file right here. So if I look at this, there is the tiny little sail icon. That's exactly the icon that we will use. And what happens if you compile this application, this PNG file will become part of your executable. You won't have to deploy it with your application. It is included in the exe file. And in order to access it, Delphi now has a very simple class, which is called tResourceStream. Instant is a constant. You just specify it as the first parameter. Then you have to specify the identifier, which has to match the identifier you used in resources.rc. And the final one is the type of the resource. There's images like bitmaps, cursors, strings for localization purposes, but in this case, rt_rc data is your winner. These things are all included in the, where we have it, scroll, right here in the WinAPI.Windows unit. Back in the day, it was just Windows. Nowadays, we have to be more specific. So WinAPI.Windows is the unit that you want to include in the users clause in order to get access to that type. And then from there, you need, in addition to the resource stream, I get a string stream because I want to create a string of this PNG file. And what this should ring a bell as well from web development, base64 encoding. And that's exactly how you build a data URL. A data URL has data, image/PNG. That's the identifier. So data, instead of HTTP, you have data, and then the MIME type, image/PNG, that's the MIME type of a PNG image, semicolon, then the encoding that is going to follow. Allegedly, this is optional. I've never seen a data URL without it, base64, comma, and then the base64 stream. And how do you get that? Well, again, Delphi has grown in the last years. You have the tBase64 encoding class that has a base64 static property with a method, also static encode, that can take two parameters, the input, which is our PNG image, and the output, which is a string stream. And a string stream has a data string property. So this way you get an base64 encoded string of a resource that's included in your binary. You might have to look at this again and again to follow the source code, but this is as concise as it gets in order to convert a PNG image that's included as a resource in your executable and convert it into a data URL. You could, if you were to copy this data URL plus the base64 encoding into the URL field of your browser, you would actually see the image. We did that in Bruges. That's the only thing that was spontaneous back then. So then you could see the little sail sign as part of the browser window. Instead of specifying a URL, you can literally specify resources. TMS uses this quite a lot in TMS Web Core for sound samples, like because web browser nowadays computers don't have a beep anymore, so they use that to play a sound sample in order to do beep, for example. So with that, you have your image encoded as a data URL, and that way you can add a custom sign or icon for your marker icon. You just need to add that as a parameter to your, or as a value to the property called icon URL. Remember, it is a URL, but it is just a string with all the information in it. And if you run it like this, now again, the sail icon will be the icon presented instead of the standard icon on the map. So if we run this again to locate participants, there we go. That's your sail icons on the map. Wonderful. The next thing we would like to do is calculate the optimal route, because I mean, if you organize a sale like this, you want to visit everybody and thank everybody, bring them a cookie or something. Thank you for participating as a seller in my yard sale. And obviously you don't want to drive here first and then drive back here and back here. So you can use FNC Maps to calculate the optimal route. So with turn-by-turn instructions, how to go from your fictional office. This is my office address right here. It's a text field. And from there to visit all the different participants in the sale. And you might think, whoa, this looks really complicated. Well, with FNC Maps, it is not complicated at all, because routing is built in now into the map component. Even back in the day when I wrote the book about FNC Maps, you still needed to drop different components. There was like a routing or directions component. That's no longer needed. This is all included in the base component. Of course, you can still use the separate components and drop them on the form, but it is all included in the Google Maps or in the FNC Maps component now. So let's go here, calculate optimal route. Optimize route is the method that I'll use. And again, it's in the view controller, and I pass, again, I need the sales ID in order to select the participants. I need the office address, which is my origin that I'll also return to. And of course, I need the control of the map in order to be able to draw on the map and also access the functionality of the map. So going to optimize route. Here we go. So again, I get all the participants based on the sales ID. And there you see how nice it is if you group these things like this in order to get the list of participants. And I got a question, I think, why do I free it and then create it again? Well, it's pretty simple. This is not dangerous, because if I initialize F participants properly when I create this class with nil, so if you call something, if you call free and your object instance is nil, nothing happens. So this is perfectly safe to just call free, and then you assign the new value from get participants. So now we have a list again with all the participants. And what we need to do next is each of the different participants is a waypoint on my route, right? I want to visit all of them. So that's what Google Maps calls waypoints. And waypoints can be specified very easily as addresses. So we can build the address of our participant. An address, this is another nice thing if you have things inside of a class like this, because the database only has street, zip, city, and state, and I defined a read-only property which then concatenates everything so that it becomes an address. So we can write code which is much easier to read in hindsight, because address is much easier to read than me doing the concatenation right there. And also address is a pretty simple example, but there might be other things that you might want to do. For example, I add USA by default here, but that might be something you want to do in the address thing that you have. Okay, I have international customers, so you modify the address appropriately. So I add the comma USA because sometimes Google Maps is, especially in the United States, a lot of cities, let's just take London or Boston, for example, they exist in the UK as well. So it's very important that you specify USA in this case. And each of these participants is just added, the address is just added to a string list. All the addresses are added to a string list, and this string list is passed to the mapping service, to the add directions method. Add directions gives you the ability, if you invoke this, you get lots and lots of overloads. You specify the origin and the destination, which is the same because we want to go in a circle, right? We want to start off at the office, we want to visit all the participants, which are the waypoints, and then we want to go back to the office. So origin and destination are the same. Yes, it's possible. We don't want to show markers because we either have the markers already set, but we don't want to do this here. And we want to show the polyline on the map where we would drive. And the polyline is supposed to be in red color and it's supposed to have a width of 2 pixels, and the opacity is going to be 50%. And I want to drive with a car. There's other stuff that you could do. You could do bike, you could do train, all these kind of things that are supported by Google Maps nowadays. And I want to avoid tolls. Of course, nobody likes to pay money if they don't need to, especially when you visit all the participants for your yard sale. And then here, this T-string list of all the waypoints you want to visit along the road. And now the most important parameter is the last one. You want to optimize the waypoints. It's as simple as that. You say, true, I want to optimize the waypoints, and boom, your route will be optimized. That's it. That's all you need to do. And with this, all the stuff is done. The route is on the map. It's painted, and that's it. The only thing that's not on the map just now is the waypoints, the turn-by-turn instructions. Those are missing. And like almost anything on the map or on the web, and Google Maps API is web-based, it's an asynchronous process. So this add directions actually triggers something, and as soon as the route has been calculated, you get an event in the mapping component right here, and that is the onRetrieved directions data event. And if you look here, you get back so-called TMS FNC Maps event data and directions data. And the directions data is of type FNC Google Maps direction data. And again, I just pass this off to my view controller, display routes. First of all, I use the routes. What is that, you might think? That is the list view right here, TList view, routes. I'll use to display the turn-by-turn instructions. And then the directions data is the parameter that is being passed to me by the event. And then this is very, very, very simple. We configure the list view with the columns. We have a step number, we have the distance, we have the duration, we have instructions. And then we say if we don't have any routes, the number of routes, a directions data to routes, or we can bow out. If we don't have any routes, we can't show anything. We need at least one. And this is something I'm not doing in this example. Google sometimes presents alternatives. Not only one route, you have multiple. You have the fastest, the shortest, and these alternatives are in this routes array. So I'm just simply going to use the first one, which is 0. And then each route has legs, and each leg has steps. And I iterate all the legs and all the steps and add for those. I add the step number, I add the distance and the duration. Distance is meters and the duration is minutes. And then something where I add the instructions, textual instructions, the turn-by-turn instructions that you see right here. And the most important thing here is these contain HTML tags for bold and italic, for warnings and stuff. I don't want any of that. I just want the bare bones text without any HTML. So for that, I used a strip HTML method, which I've written myself. I don't use anything from a library because with tregEx, Delphi can do regular expressions now. It's pretty simple. You simply create a regular expression, you look it up, and this one removes all HTML from a string, and then I strip the HTML from the string, pass the string in, get the string without HTML, and that way I can display all the routes on the form. That's it. That's the power of FNC Maps, how easy it is to add markers with a custom icon, and how to create a route with turn-by-turn instructions. At this point, I had to stop the presentation in Bruges, Belgium, and I wasn't able to present the last and final part, which is how the geocoding works. Because under normal circumstances, your database has the address information, but you don't have the latitude and the longitude. That is simply not the case. Most of the time, you don't have these. And here's the first hint. You don't see the component, but if you go here on the object inspector, we do have a component on here which is called geocoding. It's right here. It's a downside of the Delphi form designer. It is not able to show these components because FNC components are not derived of T component and thus are drawn on the form, and that doesn't work properly if you have them dropped on a form. So I can't make this visible that you see the actual component on the form. But there is the TMS FNC geocoding component. And again, this needs an API key because you can use a different service for geocoding, right? You can use Bing, Azure, or Mapbox, even if you use your map to display your stuff. So in this case, to keep it simple, I also use Google for geocoding. I assign the API key. And the process is completely asynchronous. That's the key thing with geocoding. I have a separate video on the TMS Software TV YouTube channel. The geocoding process is asynchronous, meaning you call a method and then at some point in the future, you get the result in onGetGeocoding result or onGetReverseGeocoding result. That is important to remember, meaning if you have multiple participants, and this is what makes this example so difficult, and that's why we didn't have the time to do it in Bruges, you trigger this as many times as you have participants without geocoordinates, without latitude and longitude. That's the key thing. And then your application needs to be able, when the response comes in, to update the correct record in the database, right? Because you need to be able to determine, okay, this is this address and this address has these coordinates and I need to write back the coordinates to the database. And what makes this even more complicated is if you want to give basically feedback to the user interface about the progress. And that's exactly the reason why we left it out of the session per se, but still wanted to give you the source code, because this would be a separate session of 45 minutes, how to do the geocoding properly in a multi-threaded environment. So I'm just going to give a brief explanation of the source code, and then I'll leave you with that. So if we start to follow the source code by exploring the source that I've written by going through the buttons, so we have geocode participants, that's a good start. And then again, I use my view controller, I pass in the sales ID because I need to know which sale is selected. And then the geocoding is actually the geocoding component that is on the form. I could create that in the view controller myself, to be honest with you. I didn't have to drop this on the form, but I did it nonetheless. Let's go to geocode participants. And so first of all, the geocoder needs to be stored in the class because you need the reference all the time. It doesn't suffice to keep that in the method because this is just the thing. This method will trigger the process of geocoding, but at some point the response will come in. And if you don't have the geocoder stored as a field in this class, the method geocode participant might already have been traversed completely. So the reference to a geocoder is no longer valid. And you also don't have any means to access it. So at this point, I store the reference in the field of the class, and that way it is possible that we have a reference to it when this method has ended. And then I get the list of all the participants that actually need a location, meaning the query that I use does not select all the participants, it selects only the participants that need a location. It's a different query. If we go to the DB controller here, need location is a different one. It says select left join locations where latitude is null is used. So if there's no latitude, it means we don't have the locations. So right now, if I select this, I don't have a single one that doesn't have a location. Okay, all of them have one. So I also have a second query to update the location. So I say replace into locations, meaning the locations table, not the participants table, with an ID, latitude and longitude, and a timestamp. Always use UTC. when I added this. So I have the ID for the participant, not for the sail, the ID of the participant with the latitude and longitude. That's important to have. And from there, we go back to the source inside of the view controller. The progress we'll look at later. So what we do is we show a progress form right here. Again, this progress form is managed by the view controller class. So here we have the F progress, the form. The form is created when the view controller is being created, and it's being freed when the view controller is being freed. So this form is always there in memory, but it is being shown when the geocoding process starts, and it's being hidden when the geocoding process ends. So here you see create and destroy. It's being created and freed without an owner, and that's how that is being managed, that we have a progress bar. And from there, we iterate all the participants that need a location and call the method getGeocoding on the geocoder. That's the component we use that has the method getGeocoding. And we pass in, again, the address that I mentioned previously in this talk. And this address is then being used to calculate latitude and longitude. And the second parameter is a so-called callback or closure of type TMS FNC Geocoding getGeocoding callback. Say that 10 times fast. This is the fingerprint, and you find that if you go to getGeocoding and look up the print of, this is the source code, and then you go into the callback and look that type up, and here you find the type right here, procedure, with all the parameters and everything. Copy paste it over, and that is the fingerprint of your anonymous method, which is specified as a parameter inside of this function call. And the key is that I have an L item here of tNeed location. That's my own custom type that I defined here. tNeed location, where is it? Right here, boom, right here. So here, which is just having an address, and it links back to a location. That's the key thing here to remember. And go on here. So we say if we have a successful result, that does not mean, and this is always what I have to explain to customers, a successful request does not mean that we have information attached to it. A request can be successful, but the successful result is I don't have a result. Okay? It doesn't mean it failed. A failure of a request is that your internet isn't connected, that the server doesn't respond, stuff like that. So what I do is I get the L item from a request data point. And what is that? Well, it's a little bit confusing, but we have to go and look at this call a little bit more detail. So think about this is the method that is being called when the geocoding process has ended. That means all this occurs after. So the method call actually continues after this comma here. And if you invoke code completion, you see this is the ID that you can specify. This is the ID of the request that we're not going to use. But here, the next parameter is a so-called data pointer. And there you can put something that helps you identify which request the response that you receive here belongs to. So in this case, we use it to find out what address caused this response, like which address do these coordinates, latitude and longitude, belong to. So we get our item back, and then we can say, update the location of our item with this latitude and longitude. And the latitude and longitude is embedded in the request here in items 0, the first one. So we have to check first if we have a result. This is exactly what I've been talking about. Do we have a result? The coordinate, latitude, and longitude. So the nice thing about this is, with this call, you actually hide all the database updating stuff, and you can just focus on working with retrieving the latitude and longitude, and all the database stuff is stashed away in different class. Finally, updating the user interface, and I won't be able to dive into this in detail. However, whenever you do something that affects the user interface, and we are in a background thread here, because this gets called in a background thread as soon as the geocoding has completed, you need to use synchronize in order to access the user interface. Synchronize makes certain that the code that is in there, again, we use a anonymous method, a closure, to express what we want to do. And this is being executed on the main thread. You can only access the user interface on the main thread of your application. And what it does, it calls on the form fProgress increase. And we haven't looked at this form yet. fProgress is just a bar, a progress bar, and increase does nothing but increase the position of the bar by 1. And if the position of the bar is the maximum, we close the form. That means all the geocoding has taken place. That's how easy it is to have a progress bar. And you might say, like, what happens if if you don't get your stuff back? Well, that's even if you don't have that is certainly correct. So I should not have this here. I should have this below, or that is the reason why I have it right here, below the success. So we will update the user interface if it is successful or not. We will still increase the progress, because that will make certain that the dialog will close. And the next time when we repeat the geocoding process, we might be successful with this address, but at some point, you might also mark the number of attempts you have had in the database, for example. People might specify an address that simply doesn't exist. So that is also why the request is successful, for example, but we still don't get a coordinate, for example. Still, we have to update the user interface also for unsuccessful requests. Otherwise, the progress window would never close. So the final part, how to basically update the location, is here, because each and every location has this event attached to it. And what we do is we update the location inside of the database, and we pass it in the sender property. That's basically where we get the location. And the query is the update location query, this one right here. I've shown it to you before. And the only important thing is, because I have not written this data module for multi-threading purposes like I would with Xdata in play, for example, there is only one connection. So I have to make sure that I only access this connection with one query at the same time. So what I do is I use basically I lock it out. I make sure that I enter this only once, and as it is locked, additional calls will stay here until the tmonitor exit is being called. This is formally called a semaphore, and tmonitor is the easiest way in Delphi to implement this. So this critical section right here is only accessed once at the same time if multiple calls to on update location occur, because multiple geocoding processes have yielded new coordinates. They will wait until the critical section can be entered again, meaning you call exit here, and then the next one will enter it, and then all the other threads will wait. The key thing, you have to specify some kind of token to characterize which semaphore you're talking about. So I use the query to identify it. It's the easiest way. Then you don't need to create a separate object of some sort. And with that, I know the geocoding has gotten a little bit longer, and that's actually the reason why I left it out, or why we didn't have the time in Bruges with the additional questions that I had in Bruges. I've given you all the information because I got additional questions about the data URL, for example. I've included these in my presentation to you without being actually presenting the camera view or the audio from the actual event. So thanks again for your interest in building application with FNC Maps in the VCL with a database backend.